Okay, this part we are going to look at the graphing methods. If your school teach you, to present the results of your experiments in graph, then we will have to know this graphing method. Okay, when we do graphs, choose suitable skews, don't choose obscure. So one large square has 10 small square. Okay, large squares represent 10 degrees Celsius or 50 degrees Celsius, not 7 degrees. Okay, don't 7 is an odd number, it's very odd, so don't use it. Okay, one small square as a result, if it's 10 degrees, one small square will be 1 degree, so it's very easy to count. Okay, when I draw a graph, right, it must occupy more than half the graph paper. Okay, and then at least I have to get 5 readings. Y-axis is what I observe, x-axis is what I change. Okay, this is my x-axis, this is my y-axis. If I get the value and then I plot and then I get a straight line, okay, a straight line graph, this one means this is directly proportional. So directly proportional means when two variables are directly proportional means if one double, the other one will double. One increase, the other one will increase. Okay, and then this is the same throughout the experiment. The rate is the same throughout the experiment. If the graph that I plot is a curve, okay, the speed of reaction is increasing at the start of the reaction and then it's slowing down. So how do I see this speed of reaction, right? Is a tangent to the curve. So for example, at this point, I draw a line that touches this point only, and this is the tangent. Okay, so if I have this graph and then I have at this towards the end of your reaction, at this point, I draw another tangent, just touch this point only. Okay, so this tangent is steeper, correct? This line, this tangent that I just draw is steeper than this line. This is less steep. So when it is steeper, means the rate of reaction is faster. So at the start, it's a very fast reaction. Then it becomes less steep and less steep and less steep. And ultimately, when it becomes horizontal, this one reaction has stopped. Okay, this is how we interpret the graphs. Okay, and then this is a falling graph. The dependent variable falls quickly, then becomes more slowly. Idea is the same. At the start, if I draw a tangent, it is quite steep. And then towards the end, it is not so steep anymore. Okay, reaction has stopped. Okay, do not connect the graph point by point. Draw the best fit line. Okay, because when I do some experiments, sometimes because of errors, you cannot exactly connect it point by point. So I draw a best fit line or a best fit curve. Okay, if a point is outside this best fit graph, it can be ignored. Okay, so for example, if I have a graph like that, and I plot it and your graph is like that, and then I have a point that's here. Okay, don't go and, try to do this and then go like that. It's not good, right? This point that is not within this best fit, right? This point can be ignored because this one is out, is away from your experiment. There must be some errors over here. Okay, so for your information, good to know, right? We will also have this kind of graph moving forward. Okay, so this graph and this graph, right, we will learn it in biology in your enzymes reaction, and then we will discuss it again moving forward.